All right, hello and welcome back. Today I'm going to be doing a follow-up video for Thomas Kandera. We're having a conversation about heliocentrism, geocentrism, and all the things in between, I guess. He had some comments and questions and replies to my commentaries on the mathematical narratives of heliocentrism, and we're going to go through his replies and see if we can't answer his questions. So I made a video. I told him I would keep it down to 20 minutes. And I looked over at the time and I was an hour and 50 minutes in to the reply. And I made the mistake of going through each and every reply and replying to it. And some of them are kind of the same or related in the same. Or they're not replies at all necessarily, or like rebuttals to the thing. They're just like, hey, you're wrong about this, but then he doesn't say why. So I'm going to just breeze. I'm just gonna read over them real quick, just breeze through them, and then we'll bang out some of the big ones, and we can continue the conversation from there. I will 1 second. I will, however, ask that if you're going to reply to everything, which I really appreciate you doing, don't just say like, we'll discuss this later, or not include your explanation for why X, Y, and Z is happening, or why I'm wrong about X, Y, and Z. Because on a lot of these replies, you didn't do that, and it's just kind of like the conversation. So the follow-up video would be like me going, replying to things that you're saying, and then like some of like, fuck, I'm not wording this properly, but the conversation's not, it's getting really one-sided, where like I'm doing a lot of the talking and you're just kind of like, you don't have a replacement for what I put forward, which doesn't help explain your side of things. And this isn't just for me to explain things, this is for you, to put forward your what you think about it and stuff. So don't be shy on long-winded replies, or going into detail on stuff, because if you don't, then a lot of the replies aren't going to it's just going to look like it's just going to be a really weird, fucked up conversation. you know so anyway, okay, so in this he's talking about the Dave Weiss thing, the Dave Weiss kitchen demo, right? The sun's going. So he's saying that if you replace the cardboard with the ocean, that the sun is setting behind the ocean, right? But what maybe I didn't convey properly is that one, at no point is the ocean above your head. If you're standing on the beach looking out at the horizon at the sunset, the water's rising because it just looks that way. It's an optical illusion. It's how everything is converging to the vanishing point at the horizon. So the water looks like it's rising up, even though it's under your feet, right? But it looks like it's at eye level, right? And then the sky is also coming down to do the same thing. So that's what's happening here. And then if you replace the cardboard with just level water right here, right? And then say the sky is everything above this cardboard, right? If everything's converged down to a fine point, and this is traveling on a flat, or on a level line, going straight, right? It's not going under or around the water, right? It just looks that way, is what I was trying to convey with that. And I'll show you a quick example of that. This second. So there's music at the beginning here that's copyrighted, so I'm just trying to skip ahead of it. So this is Good Times for All. He's on Globebusters every week, known as Zach. He's also known as Zachary Zimbala. His channel on YouTube is Good Times for All. You should check him out. Anyway, what we have here is we have a flashlight in a warehouse, and he just put that flashlight on the ground, and he's got his camera low to the ground, and he's just walking away taking pictures of the flashlight. And there's no cardboard, there's no water, right, to block anything. Okay, so we're gonna see what happens when a second. Yeah, okay, 2 times. We're gonna make sure, or we're gonna see what happens when you walk away, when a light source gets further away from you on a flat plane.
Distances and the angles, like precisely to see when all this stuff starts. Here you'll get the mirroring effect at this distance. It's really neat because when you focus in on just a light, all the stuff in the background goes black, almost like a solar filter.
So as he's walking away,
as you saw,
as he's walking away here, right?
This is really neat. You gotta check this.
The light that's shining on the floor, right? It starts.
The light is all the way on the ground.
It starts rising, starts getting closer to the horizon, right?
You saw I laid it down. I'd really like to be able to measure the exact.
As he's getting further, this ball of light down here is starting to merge with this one. There's nothing blocking it, nothing obscuring it, no water, no trees or anything like that.
Different distances and the angles, like precisely to see when all this stuff starts.
Dang. Further away. Now we're starting to see a mirror here.
Here you'll get the mirroring effect at this distance. It's really neat because when you focus in on just a light, all the stuff in the background goes black.
And then they're converging again.
And the objects converge, as you saw. And now here is really cool because it starts setting like a sun almost. The bottom is getting.
And now, oh, well, wait, the flashlight's setting. Well, how could that be, right? It's on a level plane.
It gets more and more. This one was a little out of focus when I snapped it. But as you can see, as I kept going, there was more and more the bottom was getting cut off until eventually you just don't see the light anymore at all. And that really, they keep saying, show me a setting sun, here you go, on a flat plane. And the light gets even less and less and less till we barely see anything. And then finally the two mirroring images can converge on each other. And there you go, the sun is set.
All right, so there you go, the sun is set. And then there was this one really quickly that I'll show you. So in the other video, I was talking about how the sun, opaque, cloud deck and all that kind of shit, and the atmospheric density. So this is what I meant by atmospheric density, because you were like, what's that? This is what I meant by that was how everything is compressing here at this horizon line. Anything that's in the atmosphere, so the water, the humidity, any atmospheric conditions, clouds, rain, weather, anything, right, is all compressing into a line right here. And when the sun gets far enough away, it will just fade into that line and not be able to penetrate it anymore, right? So that's that. And that takes care of a bunch of replies, that explanation. So we'll just kind of keep going through them here. So celestial navigation for me, it's fine too. I want to discuss the shape. Okay, yeah, so he did, to be fair, he did say he wanted to discuss the shape and stuff, and I did kind of go off a lot on this video about the alleged speed, motion, and observations that quote unquote back up the expansion of the universe and motion of the Earth through said universe and all that kind of stuff. So, you know, fair enough for pointing that out, and sorry for getting off topic on that. The reason why I just kind of gloss over the shape of the Earth is because of this right here. This is Neil deGrasse Tyson talking about space. Oh, actually, we'll start with this one. 1 sec, sorry. Neil. There was literally a 1 minute clip. How is the 1 minute clip not in here? Jesus. Just watched it. There we go. Okay. So in 2012, there was the Red Bull stratosphere thing where the guy jumped out of the balloon, right? And the fisheye lens that they were using produced an extreme amount of curvature. over New Mexico, and there was a lot of pushback from the flat Earth community about fisheye lenses and using that to fool people and thinking they see the curvature, and they even they were even calling it Planet New Mexico and stuff because it's so distorted. Red Bull fisheye stratosphere jump. Let me see if I can get you a picture of Planet New Mexico. Yeah, so they've got some extreme warping on here. This is Planet New Mexico, right? That's the curvature. So this is Neil deGrasse Tyson doing damage control for us, pushing back on the narrative. This is him saying that from 128,000 feet, you cannot see curvature, right?
This size, the International Space Station would be orbiting about a half an inch above.
So we'll just play this out real quick.
And the dude who jumped out of a perfectly good balloon, what's his name? Felix Baumgartner. He would have been about 2 millimeters above the surface of this globe. That's his edge of space jump. Now, I don't. It's fine. He wants to. I don't have a problem if he does it, but the honesty of it would greatly diminish what I think people thought he was actually doing. And not only that, they make sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. So in the
right. So he's talking about the charade of it.
This curvature of Earth's surface. He's, wow, he's in space. Look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball.
All right. So if you're 2 millimeters above the beach ball, there's no curve, right? That's 128,000 feet, 2 millimeters. So this is a wide angle lens. Wide angle lens. There's no curve, right? Neil deGrasse Tyson. I pulled it up right here. Okay.
Well, so Jeff Bezos.
This is from last year. This is in regards to Sir Richard Branson, who went 63 miles up in a plane and did a whatever the fuck they pretended to do. But anyway, this is letting everyone know that there's no curvature.
Bezos, he's actually going higher in the atmosphere to the sort of international. There are these layers where if you go higher than that, it's called space. Oh, by the way, you didn't ask, but I'm going to tell you. Do you know how high up above the Earth he was?
No.
So if you take a
63 miles.
Oh, yeah, say right. So take a schoolroom globe, and that's how high above it is he? So he's about 2 millimeters above the surface.
So I just want to point out, like,
of a schoolroom globe. So nobody has seen the curvature of the Earth.
I'll let him finish.
I just want to make that clear. Okay? That's where they were. So why do they call that space? Because you're
okay. So then he goes on to the technicalities of space as defined by different altitudes by different government agencies and whatnot. So at 63 miles up, there's no curvature. So when a lot of flat earthers and whatnot do laser observations and reflection tests and stuff over long distances of bodies of water, there's no, when they're zooming into boats and things that are out at water that are supposed to be 10, 20, 30, 40 miles away, 50 miles away, and they could see it, there's no curvature there, right? But they say that so they say that what they say now is that, oh, well, you can't see the geometric horizon. What you see is the apparent horizon, and refraction is standard refraction is lifting up what's behind the curve and bringing it to eye level perfectly, and blah blah blah. So we don't even see the curve on Earth. If we can't see it 63 miles in the sky. I don't even concern myself with like it just seems like a fruitless endeavor to even argue about it. If you can't see curvature, you can't detect curvature, then how the fuck is anyone measuring curvature? If you can't even see it, right? So that's why I just kind of moved on from that, because this is so, I feel like this kind of just refutes all of it, There wouldn't be any curvature according to them because of the size of the globe and blah blah blah, right? And there's no curvature for us because there's no curvature. So we're just We're all on that flat plane lifestyle. Let's see. Water levels, right? We'll discuss this later. Well, we should have discussed it now because now I can't rebut anything that you said because you just asked me what, like, these questions that you're asking me, like, what is that? Like, just tell me what you think. Well, I told you what I think, right? Like, it's not hard to decipher. I'm not trying to be rude or anything to you, but it's not hard to understand what I'm talking about when I say water's level and all that. To get into this and then not provide anything is it's not it just makes it hard to reply to. So can you explain Australia without it or about it being distorted? Yeah, so as things are moved further away from the equator on the maps, they get stretched out, but that doesn't mean anything because there's no way to know if they have if they've stretched out the globe to make a flat map, or if they've stretched, or if they've fucking shrunk a flat map to make a fucking globe. There's no way to know. You can do math tricks to interchange all of them. And if you want a video on map trickery, there's circling the square. My boy, I don't know this guy. Let's call him my boy. He's a good guy. Campbell from Autodidactic does a good video on how you can take this map and put it on a globe by just removing things, right? So let's say that the Gleason map, has some extra land and shit on it, or that it's bigger, further away from the equator, right? Because the sun operates in between the Tropic of Capricorn and Cancer, right in between the equators, right? So the sun's would be going around through here, doing its thing.
Can you imagine?
So it would have to be symmetrical and even and legit in this area, right? But as you got further out, you would have wiggle room to fuck around, right? And distort things and move things, extend it, cut things out and overlap them and shit. And that's what he does in this video, and he wraps this fucking thing around a ball. So it's totally how it could be done. And yeah. Not super concerned about that. Oh, one more map video real quick. This was maps have been lying to you your whole life. All right.
When you think
So in this this is just quick replies. You'll have to watch the video. I'm trying to keep this under 20 minutes and it's already at 18. So yeah, they go over the history of maps and how they're all fucking fucked up and wrong, and they all serve different purposes and blah blah blah. It's just endless bullshit. There's no way. The map doesn't necessarily mean what you think it does in this argument. So unproven of the Earth's move observation, Earth being the center. Good start. So yeah, we got some common ground here, and for the people watching at home, I just wanted to point out, common ground is always a good place to try and get with someone when you're having a big discussion like this about, things that you have, very differing opinions on. And it's good to have that foundational basis, right? So that's cool. Right, water's level, but what does that mean? Why is water level? Again, like, just say the things without doing this, because this is supposed to be you being able to say your side of it too and whatnot. So like this, we'll discuss it later. Well, now we have to come back to it when you can get around to watching the video, and then I can get around to making another one. Like, if you can, just please lay out as much as you can in the replies, because otherwise it's just going to be a lot of nothing, you know what I mean? So explaining Australia, yep, done. Let's forget about heliocentrism and start talking about geocentrism. Let's see. We don't need to go very, yeah, so we were talking about that, how it splits, where the data is coming from ground-based radar. This is wrong assertion without evidence. No, so my evidence for this is that I have a friend who works at a multi-million-dollar company that gets weather data from the NextRad weather systems, and their whole business line model and everything is they collect all this weather data, they analyze it, and they have people that, you know, they can see what's in the weather, right? So they find where there's been hailstorms, you know, things like that, where there's going to be a lot of damage and stuff, and then they sell that information to people that do like marketing and stuff for like roofers and like whatnot. Like that's just one aspect of what these people do at this company. So, and he's the CTO of the company. He built their first system, their entire system for everything, like whatever the fuck that means. He's a full stack developer, right? He made the whole fucking thing. And then they had him rebuild it a few years ago, and I think he just finished it recently, or is almost finished with it. But anyway, he would absolutely know if they were analyzing any data from satellites. Okay, none of it comes from, and he's a globe guy. Like he's not like this would be a big proof for him if he could have used it. It actually all comes from the NextRad radar systems that are ground based. 100% of their data. This is a multi-million-dollar company. The more data that they can get, the more they can, you know, if there was satellite data to get, these guys would have it, right? And they don't, because there's none. At least not that's publicly available. Because if it was, it would be part of their repertoire, right? And it's not. And he would know because, like I said, CTO. And I know that's kind of like, oh, well, you have this special magic friend that can verify your story. Yeah, I mean, you know, it's just so happened. It just so happens, right? So I feel really well rounded in saying all that. I mean, really confident in that because I've got firsthand knowledge of the guy who could back it up and backs up my claim that it all comes from ground-based radar, and he would have loved it if it didn't. Foucault's pendulum is a good evidence, but it's too complex. But see, if it's complex, but you know about it and you could go into it, do it, please, because now I'm just going to be reiterating what I said in the video, and that's not a conversation. I have nothing new to refute. No, having the magnet do it and keep it all working completely nullifies everything about what they claim the Foucault pendulum does. So I disagree. You would have to go into the complexity if you want to present some additional insights on it. The clouds we see are very close to the horizon, so atmosphere. So atmosphere we'll touch on real quick, and the celestial sphere and all these spheres, right? The Atmos dome, right? Because a hemisphere, or I'm sorry, a dome is just half of a sphere, right? So just look at it like that when I'm saying it like that. It's not the air doesn't curve into a sphere. No gases. Gases take the shape of their container too, don't they? Like they don't just, there's not just gonna be a fucking spherical thing going around with no barrier to give it that curve, right? So clouds right below our feet. How far? No, there's no need to even compute it, because if you're standing at a beach looking out the horizon, and you're 6 feet tall, the maximum they could say is that you could see is about 3 miles, right? So everything's converging at that at the horizon at what would be about 3 miles, right? The 8 inches per mile square, blah blah blah, would come out to about 3 miles at 6 feet. So that's the answer to that, is that about 3 miles of distance and it all converges to the fucking ground, bro. So, you know. And again, at 63 miles up, there's no curvature. So on the surface, there definitely can't be any. At least none that's going to block anything, right? Which is why they've now shifted the horizon being geometric to the horizon being apparent, because it's not physical, right? You show nothing works on a flat Earth, and forgot to use a. And forget about the flat Earth and use a geocentric model for what's in this video. Was this the? And let's see. Now we're gonna move on to. Oh, well, it was before that, right? And they tried to prove it, and they couldn't. And they were like, "Oh well." I don't fucking know. 50 minutes. And I don't know. Not sure, but I think where you're having some issue is you think that all the geocentric models are spherical shapes. Is like a sphere inside of a celestial sphere or something like that. Doesn't have to be. It can be a level plane with a dome over top, and then like in this, it has layers of domes, right? The egg shit. It's got a thing underneath. But yeah, this is a plane. If you go to Norse mythology images and let's see. So I'm just trying to make the fucking picture bigger. All right. So yeah, this is a dome. Now see, this is where it gets kind of interesting, right? Because the plane, right? The level plane is a level plane with a dome over top of it. But there could also be a dome under it that does some shit. But I don't think that's the case. And furthermore, I think that the thing that we live on is a level plane and not a sphere itself. I think just the sky is what's spherical. So yeah, when you hear me refer to something as geocentric, I'm aware that most people think that means that, oh, a spherical Earth, stationary sphere Earth, but that's not what I'm talking about. I'm talking about that old shit, brother. If you go back to all the ancient civilizations cosmology, it's all this. They've convinced everyone that the celestial dome is a celestial sphere. That's just how they teach it now. They teach us that there's people underneath your celestial dome that are upside down relative to you. It's all gobbledygook. See the fallacy. You had to put a physical object. So this was the thing which we went over at the beginning. Eclipses are predicted and recorded from data from thousands of years ago. That's wrong. A bit too complex. Where did I say that? Yeah, they've got thousands of years of data, right? And you can even find that on NASA's website where they cite that. Did I show it? So that's enough about. Oh no. Okay. This website. So all eclipse, this is from NASA. All eclipse calculations are by Fred Espernak, and he assumes full responsibility for their accuracy. So NASA doesn't predict them. The heliocentric model doesn't predict them. Fred Espernak predicts them. And he does it based on data from all these different, what's the word from them? I want to say datum, but I don't think that's the right word. But all these different data sets are just collected and modeled out eclipses based on, previous observations that were recorded over history or whatever, over time, from older civilizations. And all of them knew that, close celestial, like that the celestial sphere that they use for celestial navigation, right? They knew that was close and local, that there was a celestial dome, right? We're just told in modern times about celestial sphere, right? To give it this this globe shape, to give us that full spherical shape, but it's just a dome. It doesn't have to be an actual sphere, because any point from where you're navigating on from the plane, from the plane, from your perspective, everything is going to be happening within that dome. All the stars you're referencing are going to be everything that is renderable to you in that hemisphere, right? So it wouldn't matter. It would still be half of a dome no matter where you're at. Now, the thing that makes me go, okay, well, it's flat, is because when they do the circles of equidistant altitude for the triangulations that that they produce from making the celestial triangle in the first place, implies that all the surrounding area in that circle of equal altitude is flat, right? And then you run multiple circles at different distances to get your triangulation, right? So all the circles that you've referenced that are overlapping at a certain point, all those circles are all flat, all the area in between that. So that's just how I've reasoned it. Let's see. Solar eclipses, yep, did that. Land obstructions, covered that already. Just from the Dave Weiss thing. Those documents aren't saying the actual shirt's flat. Yeah, so I went back to the PDF and checked out some of those. Yeah, some of them don't reference it in the way that I was portraying it in this, but I will say that, hold on one second, that I have seen them where they did reference it exactly how I was saying. And what was further explained to me by some people that I was talking to about that was that, well, it just makes the math easier, blah, blah, blah. I will concede the point on the fact, or the reference of how they model it on the fact that basically the way the scaling would work, how they say the globe is so big and whatnot, that they would actually be flying over a flat plane and all that kind of shit. So I can give way to how they're presenting it on that, because I can see the globe argument side for it, and it's not a make or break for me, so I can walk away from that one. So fair enough. There's no curved water. So that was in reference to the mirror imaging on reflections of lakes and stuff like that. Fair enough, but it's flat enough that the reflections don't appear to be distorted in any meaningful way. And that would have to be, the water would have to be pretty fucking flat for it to produce that effect without any distortions or bending, right, in the reflection itself. Before you try and throw random guesses, try and see that it's flat. Let's see. These maps of, okay, yeah. So that's not a random guess. That was me explaining why I don't think that that there's like an infinite plane or like more land outside of this, of what's called, the ice wall, right, in our cosmology, in our worldview. I don't think there's land outside of here. I think that's indicative to how this magnetic field works and how it goes back to the center. That explains the magnetic declination, how it gets so crazy at the as you get further away from the equator. If you get out here towards Antarctica and stuff, they have like 175 degree magnetic declination. So you're basically just turning straight around and shit to get where you're going. And that's basically, I think, because this magnetic toroidal field wraps around. I think that's how it works. Like, I think that this is the end of it. Like, if there's not an infinite plane. I wouldn't say that that's a random guess. That's me trying to deduce where we live from the information that we have about it. Pretty much all I wanted to cover. So you have an incoherent, contradictory narratives that can't predict anything relative to day and night. Duration at Strasbourg, whatever. No, I'm sure it does. I'm sure it can be done. I just don't know how to do it, and it's not a make or break for me either because it doesn't. This doesn't matter. Explain to me how this is significant to the Earth being a globe, because you've brought it up and stuff, but you haven't really hammered it home in this. And I don't want to have to do a follow up video because we're having these conversations where it's like, we'll come back to it later. So please just lay it on me. And the incoherent, contradictory narrative. I mean, if you listen to me walk through the narrative of how they try and explain the motion of Earth and the lack of detection of that movement and spin, and also the expansion of the universe and stuff, that whole like that's all contradiction narrative, blah blah blah. Like do you have any thoughts on that? Or anyway, let's see. So the globe celestial navigation. No, we are not necessarily, because the way they do it is they make a celestial triangle, which requires the way that they do it requires a flat surface. Right? So I've often heard, you can get a triangle from a curved surface, right? But that's not even what they're doing. So, I don't think so, man. When the math checks out, I'm not super concerned. So basically, you're not doing science. What's that in reference to? On a lot of stuff. Like, I'm not super concerned with it. You know what I mean? Because they've had a lot of time to work on this model, and these people that have worked on it are really fucking smart. Yeah. Yeah, no, I'm not. No. No, because you can make a mathematical model to do anything. When they made the Lorentz transformation to explain their experiments on why there's no motion, like that's a wrap, dude. There's no science in the math that they produced. That's why I'm not super concerned with when they say the math checks out on it. They can make the math do whatever they want, and they've had like 300 years to fucking work on it. So, they're not even doing science, bro. They did the science, and it didn't go in their favor, and they used math to philosophically ignore it so they could maintain the Copernican principle. Right? So when you're a geocentrist, we'll discuss it. Just discuss it now, because this is, what even was the point? And let's see, Lorraine GPS quotes. Yeah, okay. No, so this was touching on. You think that I am unaware that geocentrism refers to a spherical Earth, but what you don't know is that there's also a flat plane of geocentrism where the sky is just rotating above us instead of a sphere. So I think that's where we differ on that. Heliocentric model, interchangeable. Yep. I'm afraid same thing, right? And by the way, the principle is not geocentrist. I don't know if you're talking about the movie The Principle or the Copernican principle, because that's what I'm talking about when I'm referring to the principle. Their philosophy that the Earth can't be in a unique position, and we're just a random accident and all that shit. So my bad. Yeah. So no. So you don't know that there's a level plane of geocentrism. Oh, okay. With referring to Earth, we forget about the spinning, but the Earth has a globe. So Yeah. No, if it's not spinning and everything's not expanding, and no, I mean I'm not ready to concede that it's a level plane, because I've now given you further in-depth explanations of how the optical effects we see in the sky are a result of our um, perspective, right? So, and I gave you several demonstrations of it. So I'm not quite ready uh, to concede on that. Side view, totally wrong. Not how perspectives works.
With somebody living upside down.
Well, even still, the model on the left is exactly the same thing.
And that's the biggest, fooling point of the entire thing. Is that no, you exist in your personal atmospheric dome. That's how you see things. When you watch a plane fly.
Like, yeah. So I don't know if the lines on that were, particularly accurate or whatever to how you're thinking it. And you say, like, in this we must discuss, but like we didn't. Did, like, do it next time, please. Discuss it, like, in detail. The side view is totally wrong. That's not how perspective works. All the lines should, like, but like, can you, like, what do you mean? Even if the lines weren't correct, like, it's still portrayed exactly what happens. So we'll have to go in depth on that. Let's see. Small challenge for you. Who made this? Is the Walter Bisbin thing? I don't know why he made it, but just, if you can't, I can do it for you. Just tell me what you know, brother. That's what we're doing this for, so we can exchange information. But I think you need some critical skills manipulating those people. Yeah, right. Okay. P.S. Know how this part is contradicting. Sunsets because of our perspectives. Sunsets because of the personal dome. No, the personal dome is in reference to how perspective works. Our perspective is rendered to us from the personal atmospheric dome, so it's just kind of like interchangeable terminology. It's not He's not talking about two different things. I could see how that might have been unclear though, or whatever, So all good. I'm fine with the geocentric model. Do you accept it? Remember, it needs the globe to work. Doesn't though. Doesn't. And all the see, here's the thing too. So the Norse, the Norse mythology people, the Vikings and all that were navigating by sea and stuff. They all knew we lived on a level plane. They had celestial navigation. Didn't require a globe. I hope maybe through this video and the responses, you can kind of see that, oh, well, not everything does require a globe, right? Because I'm getting the sense that you're a geocentrist. Simple. I haven't even looked, actually. Simple. Yes. Let's see what this is. Okay. No, it's not what. HD, let's check this. I, sir. Let's see, at the center zoom. Yeah, I honestly don't know what the what's wait, okay, so the green square is some fancy straight line to the horizon. Oh, okay, I see, I see. So the green would be the apparent horizon, and the horizon represented by the circle is the sphere. Wait. Top right one. Center is details of. So as we're turning towards the green, horizon on a sphere. Yeah, I don't know, man. You'll have to walk me through that. Perspective. Let's see. So is there perspective? Yeah. So again, these two are. He just kind of set them differently, even though, um, that's not. He was just like making a list. You know what I mean? But same thing. And then refractive index. Set the polys up. Simple extra. Well, no. So it's super simple. The way that I showed it to you with the flashlight and shit on the concrete floor. There's nothing more simple than your perspective does it when everything converges at the horizon. So, the reflection is curved. So this was in regards to the lake thing. Don't imagine star trails at the horizon on a sphere. Compute and try. Well, like, just why don't you just do it and then like show me? Yeah, I have no idea what you referenced. I watched that earlier. I'm just trying to keep this short. It's already at 47 minutes. Predictive model. There might be some science here. Wait, there's no such thing as flat Earth. Why not? What is this part? Data. You know, if you look at how eclipses are predicted, you'll find that no, we did that with the Fred Asperneck thing. It's not. You were incorrect about that. Why water level is not flat? Wonder why. Tell me, dude. Tell me why you think it's not. You don't understand about the treaty. You've been hoaxed. No, I haven't. You can go to conspiracy. Sorry, Antarctica's closed. No, you can go here and he'll read it right from the paperwork and he'll explain it to you. He's a lawyer as well. So he'll explain to you the legalese of what they're conveying. It's kind of like in plain English too. Like you can just kind of understand what it says. No, they can't. I haven't been hoaxed about that at all. You can't freely travel there. And man arrested for traveling to Antarctica. Yeah, Norwegian man arrested. Blah blah blah. Yeah, so this is just there's another guy there on an illegal trip. So what's an illegal trip? What does that mean? Oh, without permits, insurance, and oh, so like being beholden to a treaty. All right. So I'm sorry, I didn't mean to. I'm starting to get like kind of like an attitude and be short. I apologize. I don't mean to be that way. I recorded this. I tried to make this a 20 to 30-minute presentation. I'm at 50 minutes and I'm just re-recording the exact same thing to get through these replies, but this is a lot cleaner than the last recording, so I will say that. So, but I'm sorry, I'm just kind of I literally just repeated it, and I'm just kind of exhausted from doing it for the second time. Not your fault, and I apologize if I was starting to come off as kind of rude there. It's from fatigue. It's not from you. So you were hoaxed about that? No, definitely not. You can, like I said, go watch that video. Look up the treaty itself, and look up people that have been arrested for trying to break it. So, you were plain wrong about the balloons and GPS. No, I sure wasn't though. The light squared thing is a 4G LTE ground-based system that completely is indistinguishable from quote unquote satellite GPS signals, and that's why they had to discontinue the project allegedly. And the balloon stuff, no, the balloon stuff absolutely works. So if you take those NextRad radar systems and you look at how they have America covered, apply that to what a balloon would be able to do, and it would take about 3,000, give or take, balloons to cover the entire map. You know, the entire Gleason's world. That Gleason's map would take 3,000 balloons to cover it, to get coverage over pretty much everywhere, right? Or at least the relevant places. Like, you wouldn't even have to have them everywhere, right? Because there's places where there's no GPS signal and all that kind of stuff. So yeah, and then if you look at the actual NASA videos on the balloon tech, they have they totally have the manufacturing scalability to make 3,000 balloons a day easily. So that's not even an issue for them. Like, that's not even the hurdle that they would have to overcome for that. So the thing with the kitchen is a fallacy. We went over that already. That's not. Level is curved, right? No. So this day night thing, and no. And then, yeah, those are pretty smart people, so that's why they can do science. And we'll discuss the principle when you become a geocentrist, not before. Well, we should discuss it now, because you're not going to convince me without having the conversation, right? You know, so just make your points, and if it resonates and and it makes sense, I'll be forced to either reconcile that or go into like crazy denial, which I would like to think I would reconcile it if you made good globe points. But I've been at this for a while now, and I've seen lots of different arguments, and I haven't seen one yet to send me back to the globe. So let's so yeah, these scientists and stuff. So yeah, they're smart and all that, but they've been completely subverted into not even doing science. They just do math, right? And that's kind of the problem here, because if you do math, then yeah, you could say the Lorentz transform explains why there's no motion of the Earth that can be detected, because any apparatus you try to use to measure it would shrink by the exact amount that would yield a result that would make you think the Earth is stationary. So that's where I'm at on that stuff. Yeah. So anyway, so that's the conclusion to the reply, and I don't know if English maybe isn't your first language, and that's why you don't want to come on and have like a back and forth or anything like that, which is totally fine. But it would be cool if you wanted to do that, because then we could just have a conversation in real time, and like I could show you a video or something or a clip, and then you could show me something, because I'm a very visual person. Like, I really need to see it, and then if you could like walk me through what you're saying and stuff, or like why where you're coming from on things, I think that would help a lot. But yeah, it just if you have a rebuttal to something, please explain where you're coming from, because if you just say like, we'll talk about it later, or ask it in a way like what is like trying to like lead me to answer the question. Don't do that, because I'm trying like it's not going to go well for the format of how we're communicating, right? Because it needs to be concise and all in the same spot. You know what I mean? Because now to get answers to some of these questions and then explanations and stuff, I'm gonna have to wait until you can reply to it, or till you could watch the video and then reply to it, and then you'll have to wait for me to go read your replies and make a video to it when I can get around to it. So just trying to maybe speed up the process a little bit, but yeah, just try and put it all forward, so that way when the reply videos will have more substance to them, so I can have something to further elaborate rather than just reiterate what I already repeated without giving you a new perspective on it or something like that. You know what I mean? All right. Well, thanks again for coming by the channel and and having this conversation and stuff with me. Really appreciate it. Look forward to hearing your replies.